All right, guys, Miss Adams again, and we're still looking at the Unit 3 test review. We're on page 2 now, so we're starting with problem 5. It says, if f of x equals 3x minus 7 and g of x equals negative 2x plus 5, find each of the following. So we're evaluating these functions depending on what it's telling us to do. So it says f of 5, which means we're going to take our function, our f of x, and anywhere we have an x in that function, I'm going to replace it with 5, which means I'm going to have 3 times 5 minus 7. So that gives me 15 minus 7. So my f of 5 is going to be 15 minus 7, which is 8. Now let's look at the g of 0. So I'm going to use my function g of x, but anywhere I have an x, I'm going to replace it with 0. So I'm going to have negative 2 times 0 plus 5. Anything multiplied by 0 is 0. So this is going to leave me with 0 plus 5. So g at 0 is just 5. Then I have 3 times the function of f of x. So I'm going to take 3, and I'm going to multiply it by my f of x, which is going to be 3x minus 7. I'm going to have to distribute the 3 to both terms. 3 times 3x. Excuse me here. Is going to give me 9x. And 3 times negative 7 is going to give me negative 21. Remember, we're using our f of x, which is this function originally given to us in problem 5. Now D says f of x minus g of x. So I'm going to take that function f of x, which is 3x minus 7, and subtract g of x, which is negative 2x, plus 5. If I subtract an expression, that means I'm going to be multiplying by a negative 1. So it's going to change my subtraction to a positive, and it's going to change my signs inside. So negative 2x is going to become a positive 2x. Plus 5 is going to be plus a negative 5. Then I combine like terms. I'm going to have 3x plus 2x now, and then negative 7 plus a negative 5. 3x plus 2x is going to give us 5x. Negative 7 plus a negative 5 is going to give us a negative 12. So our simplified version is 5x minus 12. E says f of x plus 2 g of x. So I'm going to take my f of x, which is 3x minus 7. And that's originally from the beginning of 5. And I'm going to add 2 times my g of x, which is negative 2x plus 5. Distribute the 2 to the second expression. So I've got 3x minus 7 plus negative 4x plus 10. And then I'll combine like terms. I've got a 3x and negative 4x, negative 7 plus 10. 3x minus 4x is going to give us negative 1x, or you could put negative x. Negative 7 plus 10 will give us a positive 3. Part F says if f of x equals 26, solve for x. So now instead of plugging in 26 for our x value, we now have 26 as our y value, or that's what our f of x is equal to. So I'm going to have 26 equals our function 3x minus 7, and I have to solve for x. First step is going to be to add 7 to both sides. 26 plus 7 is going to give me 33. So I have 33 equals 3x. And I'll divide out a 3. And that gives me that x equals 11. Part G says if g of x equals 19, what is x? So I'm going to say 19 is equal to my g of x, which is negative 2x, plus 5. I'm going to subtract a 5 from both sides to isolate my variable term. 19 minus 5 is going to give me 14. So I have 14 equals negative 2x. And then I'm going to divide both sides by negative 2. So x equals negative 7. It says if f of x equals negative 13, what is x? This is part h. So I've got negative 13 is equal to f of x, which is 3x minus 7. I'm going to use the addition property of the equality, so I'm going to add 7 to both sides to isolate my variable term of 3x. Negative 13 plus 7 is going to give us a negative 6, and that's going to be equal to 3x. And I'm going to use my division property of equality to divide by 3 on both sides. So x is equal to negative 2. And there we have it. And we do have a bonus problem here at the bottom. It says evaluate f of 2 plus g of 5. So that means for my function f of x, anywhere I see an x, I'm going to plug in 2. So I'm going to have 3 times 2 minus 7 plus my g of 5. So I'm going to have negative 2 times 5 plus 5. If I look at my first set of parentheses, 3 times 2 is 6, and 6 minus 7 is going to give us a negative 1. And we're going to add to negative 1. We've got negative 2 times 5 gives me a negative 10. Negative 10 plus 5 gives me a negative 5. Or, excuse me, yes, negative 5. So I've got negative 1 plus negative 5. That's going to give me a value of negative 6 for this bonus. Now let's look at number 6. It says write the recursive formula, the explicit formula, and the function of the given table, then give the domain and range. So we're given this table where our n values are 1, 2, 3, and 4, and our a sub n values are 23, 21, 19, and 17. That means our a sub 1 is 23. Likewise, a sub 2, a sub 3, a sub 4. So those are our term numbers. And our initial term is 23. If we write the recursive form, we've got to figure out what's the difference each time. So I'm going to erase these so that we can actually look at the difference here. If I go from 23 to 21, I'm subtracting 2. 21 to 19 is also subtracting 2. 19 to 17, I'm subtracting 2. So my overall difference is negative 2. So my recursive form is going to be a sub n equals a sub n minus 1 minus 2. Then it asks for the explicit formula. That's going to be a sub n. And I'm going to add in my a sub 1 value, which is 23, plus n minus 1 multiplied by our difference, which is negative 2. We're going to use the distributive property to multiply the negative 2 through to my parentheses. So I have a sub n equals 23 minus 2n plus 2. Combine like terms, I've got a 23 and a 2 as my like terms. So my recursive formula is a sub n equals negative 2n plus 25. It asks if it's continuous or discrete. Because it's a sequence, it is discrete. That means they're not connected. Our domain is 1, 2, 3, and 4. These are our term numbers. The range is going to be the actual terms. So I've got 23, 21, 19, and 17. And if I write this as a function, I'm going to take my explicit form. Anywhere where I see an n, replace it with x. So it's going to be negative 2x plus 25. Let's look at number 7. It says, given the graph, write the first 3 terms, explicit formula, and the function, and then give the domain and range. So if I look here, I've got to look for my a sub 1. So that's where x is 1, a sub 2, a sub 3. Now I can keep going on, a sub 4, So I've got where a is 1, my y value is 2. So my first term then is 2. Then if I look at my a sub 2, my next value is going to be where y is 3. If I look where x is 3, I'm going to look for the y value that corresponds to that, and it will be 4. And we can continue on from there. If I write out my explicit formula, I've got to figure out first off what is my difference. So in this case, I'm going up by 1 each time with my y value. So my d equals 1. I already know my a sub 1 is 2. And remember, if you need a refresher on explicit formula, this is a sub n equals a sub 1 plus n minus 1 times our difference. So I've got a sub n equals 2 plus n minus 1 times 1. Anything multiplied by 1 is itself. So I have a sub n equals, I can 2 plus n minus 1. So my a sub n equals n plus 1. Is this continuous or discrete? This is a continuous function. Notice that we have a line throughout this. It extends from negative infinity to positive infinity as our domain, as does our range. So this is a continuous function. I can write this function as x plus 1. Our domain is going to be all real, so negative infinity, positive infinity, as will our range. It's going to be negative infinity to positive infinity. Now let's look at problem 8. It's going to continue on to the next page a little bit, so we'll actually pause on problem 8 and we'll continue that in the next video. Thanks, guys.